All of you are able to hear me and see me because I can only see the PowerPoint. So today I'm going to talk about, the title is self-explanatory, what breathes fire into the equation. So to actually understand what we are talking about, I would like to start with a very simple example. But before I go there, during the talk, if any of you have any questions, please feel free to interrupt. And I cannot see the Google Meet screen here on my screen. I'm only seeing the PowerPoint. So maybe I request, Denny to interrupt me whenever there is a question or something like that, so that, we can talk about the question.
I will do that, sure.
Right. And so let's get started with this. So there is a very interesting book which has also been made into a movie called The Hitchhiker's Guide to the Galaxy. So some of you may have read it or aware of it, and there is a very interesting episode in there where they have a supercomputer, some super quantum computer, and they go and ask at the answer to the ultimate question of life, the universe, and everything. And it takes several days and years to compute and do something, and then at the end it says answer to the ultimate question of life is 42. So as you can see, that doesn't make any sense. What do you mean by answer to life is 42? Unfortunately, our science today has become like that. So it is a very ironic thing that science has begun with searching for ourselves to know who we are. And today we are stuck in this numbers. We're stuck in what I call the empiriometric method, which we will talk about. And why this is a problem? This is a big problem because all the discoveries in physics are now discoveries of new equations. So for example, you would see that there are 4 Maxwell's equations are often written down and said, this is light. And if you look at Maxwell's equations, they are explained as changing electric field causes magnetic field, and changing magnetic field causes electric field. That is circular, meaning electric and magnetic fields are just causing themselves and there is nothing else. But that's how equations are being interpreted. And even worse with Schrodinger wave equation, which I will talk about in the next few slides. And this creeps into our culture and our very way of thinking and makes us nihilistic. Meaning, for example, even scientists and physicists often explain atom as there is an electron and a proton with a lot of nothingness. But we must ask ourselves the question, what is this nothingness? Does nothingness exist? In fact, if you hear anybody explain, universe, physics from a physics point of view, you often hear this Big Bang theory. These are essentially solutions to Einstein's field equations. And if you extrapolate it back into time, it is viewed as if, the universe came from nothing. But what is nothingness? In the movie series Matrix, there is a scene where the protagonist, Neo, meets a boy who is a monk when he goes to meet Oracle. And the boy holds a spoon in his hand and he is bending it. And Neo is fascinated by it. Then the boy tells him the trick that he says that don't try and bend the spoon, that is impossible. Rather realize the truth that there is no spoon. So here we must notice the sentence, there is no spoon. How do you know that there is no spoon if you don't know what a spoon is? There must be a spoon, and hence you know the spoon, then you can say there is no spoon. So no spoon is indicating the absence of a spoon. It is not real being, meaning real being is not a human being, being meaning something that exists. A real existing thing is the spoon. No spoon is not a real existing thing. No spoon is a mental construct. I know spoon, that is K-N-O-W, because I have seen a spoon in physical reality. A physical spoon is what exists. No spoon is a mental construct, the absence of a spoon. For example, I can say there is something because I can touch and feel and see that something has physical existence. But what is no thing or nothing? That is absence of a thing. That is a mental construct. We know nothing because we know something. From our idea of something, we abstract, we have a mental construct called nothing. But this nothingness doesn't exist in reality. So there is no nothingness in reality. Nothingness is non-existence. So if nothingness is non-existence, how something, because we are able to clearly see a universe that is something, that there are physical things in this universe, how can this something come from nothing? That violates the very foundational principles of physics. Yet, this is often used to explain the universe. And more importantly, if you look here, time is put on the same footing as space. For example, if you are standing in front of Mandir gates, you can see the road on both sides. One going towards the institute, other going towards Gopuram Road. You can see, both ways. So you can see these points at the same time. But time is not like that. We imagine this time axis as if there is a time that is running in the background, and we don't really pay much attention to this. We use it as a mathematical tool, and it gets lost in the equation, and we don't really spend time to understand time, unfortunately. So then it becomes very mathematical, and this leads to even more problems, like things like wave-particle duality. Some of you are in second BSc, so you may not have studied wave-particle duality, and even third BSc students may only recently started learning this in quantum. But wave-particle duality is often summarized like this: that waves like light could behave as particles, and matter particles or things like electron could behave as a wave. But this violates the very principle of logic and the very principle of identity. What is the first principle of logic? That is, you either have X or not X, meaning it is either raining or not raining, or a car is completely red or completely black. It cannot be both completely red and be completely black at the same time. This is also called as the principle of non-contradiction. So we have a physical thing we are saying that violates this very principle of non-contradiction or principle of identity. This means we are basically invalidating all the experiments that we have done to come to this conclusion, meaning that this conclusion itself is invalid. Because all our experiments, all our thinking is based on principle of identity. I'm able to do an experiment in my lab. I'm able to measure a laser pulse in my detector and know that the result I get is faithful representation of that laser pulse, because I know that that laser pulse would not change without any cause. And if it has changed, then there must be a cause. And a laser pulse, when there is nothing else affecting it, it is what it is. It doesn't change. I know this, and that's how I'm able to measure it and understand that that's a faithful representation of whatever the pulse actually is. So all our measurements, all our experiments are based on principle of identity. That is, A is what it is. A is A. X is X. X cannot be both X and not X at the same time in the same way. If we begin with that, no experiment is possible, no knowledge is possible, because we cannot know anything. Because if you try to know something and you don't know whether it is X or not X, then you don't have any knowledge. But this is what we study in physics. This is what is often used to describe quantum mechanics. In fact, this is the first lesson in quantum mechanics that we say, oh, waves behave like particles. It's either a wave or a particle. It cannot be both. It cannot be both electron as a particle and a wave. And what do we mean by a wave actually? By a wave, for example, if you take light wave, we mean that it is changes in some property, like changes in electric field or magnetic field. That's what we mean by a wave. That is a change in a property. But what do we mean by a wave when it comes to matter, or when it comes to particle nature to light? What do we mean by that? We don't really understand it. And unfortunately, our textbooks are, for example, David Griffiths or Amit Goswami or other standard quantum textbooks that are used. These are basically teaching you a mathematical recipe. This is what is dubbed by an MIT professor, Kaiser, as shut up and calculate approach. That you have certain mathematical rules. It is like learning how to make paneer tikka masala. You have a recipe. You are not making paneer, you are not making the vegetables, you are not doing anything. You are simply following the recipe, cutting the paneer, cutting the vegetables, and making paneer tikka masala, and you are satisfied with that. And that is how physics is being taught, because we don't actually go back to the basics and ask, how can we have wave-particle duality that violates the principle of non-contradiction? And unfortunately, even people like Heisenberg have thought that they have disproved the principle of non-contradiction, the very principle on which the entire physics is based on. Then if we disprove that, then we are basically invalidating the entire physics. So being stuck in equation-only physics can lead to misunderstanding, even in very big scientists like Heisenberg, for example. And then there is the Schrodinger's cat. This is something that Einstein and Schrodinger made up to tease quantum mechanics, to make fun of the standard Copenhagen interpretation of quantum mechanics. That is, there is a cat in a box and there is a radioactive material, and if the radioactive material decays, then the hammer falls, breaking the poison vial, and then the cat breathes that poison and dies. But this radioactive material decay is something that we don't know when it happens. We say it is random. What we actually mean by randomness, we don't say. We mean by randomness often something that occurs without a cause. How can something be causeless? If you're saying that this radioactive material decay is random or is causeless, then we are basically taking all our physics and making it irrational. Because to know the reason, to know the cause is the rationality of physics. But when we say randomness, we often mean that it is causeless. So are we being irrational in quantum mechanics? Was what Einstein and Schrodinger wanted to convey through this experiment. So it is today used as a thing to say that cat is both dead and alive. And there is no difference that is made between our knowledge of the cat being dead and alive and the actual cat being dead and alive. The actual cat is either dead or alive. It cannot be both alive and dead, the actual cat. It is our knowledge that we don't know whether the cat is dead or alive until we look at the box, but that does not change the reality of cat being dead or alive. The cat is either dead or alive. The cat, we cannot say that the cat is both dead and alive. It is our knowledge of the cat that we do not know, but there is a reality. So by starting with this, especially in the Indian context, we often subscribe to philosophical idealism. What do we mean by philosophical idealism? That is, we think ideas are the first. Typical example of this is, I think, therefore I am. That is not right. You exist even if you don't think. Your existence is primary. You exist, I exist, therefore I think, and that's how I know myself. But my existence is first. To negate the existence over ideas, that, for example, to say that this is all matrix, this is all Maya, that there is no reality, is the philosophical idealist approach. But there is a reality. If I say that I am a part of some mithya or some Maya, of some being or something else, where is this being? Even in the Matrix movie, People are living in matrix, but their real bodies are somewhere. There is a reality. There is a city called Zion. There is a reality. They may be in the matrix, but there is a reality. So even if I think I am in Maya, or that there is no reality, that I must be there somewhere, because I am saying I am not there, like there is no spoon, then that idea of I must be there somewhere in reality. So how do we set all these things right? What is it that we have done wrong, and how has it led to this cultural decadence? Like being stuck in this equation only physics, you see books from very big physicists like Steven Weinberg or Lawrence Krauss or Stephen Hawking. For example, Stephen Hawking in his book Brief Answers to the Big Questions says that we don't have need for a God. The way he explains it is, the space is negative energy, matter is positive energy, so if you combine them, it is all zero energy, so there is nothingness. But that's not nothingness. Nothingness is non-existent. So modern physicists are not rigorously trained in philosophy. Modern physicists are rigorously trained only in mathematics. Although we obtain doctors of philosophy, we have limited philosophy to an armchair discipline, and we have completely removed it from physics. This has affected other fields like biology, where they cannot define life, or where they cannot define anything, but they think that explains everything. Like, for example, Richard Dawkins writes in The God Delusion that God doesn't exist, but Richard Dawkins doesn't understand science. He claims to be a scientist, but if you ask what is the thing, they often subscribe to this idea of evolution. Yes, idea of evolution is correct, but evolution, what is evolution? The first step in evolution is that there is a mutation which is random. And then the second step is that there is natural selection. But the first step, if you question what is this randomness, then the answer you get is that it is spontaneous and it occurs without a cause. So are we saying that our life today, that a human being's body, which has this beautiful organization, beautiful functionality, came from randomness without a cause? Are we saying that we are irrational, rational creatures? So evolution itself is a schematic method that sweeps things under the rug by ascribing it to randomness without really understanding what randomness is. Same thing with the physics book, The First 3 Minutes, where Nobel laureate Steven Weinberg describes the origin of the universe in the first 3 minutes, and the way we interpolate our field equations in this time is completely irrational, because we go back to saying that there was a random fluctuation in some field and that led to the universe. Again, we go back to the idea of randomness without actually defining or looking into what this randomness is. And that's why this equation only physics has led to a decadent society, because we are human beings and we have life, and in our life we have only one fundamental choice. The one fundamental choice that we have is to either live or not to live. As human beings, we can either choose to live or choose not to live, but we have chosen life as a value. If we have chosen life as a value, what is the ultimate nature of life? What is the ultimate value of life? It is to grow. And when we say our value of life is to grow, how do we grow? What do we mean by growth? By growth, we mean that we look for the truth. We understand what reality is, because all our growth must conform with reality. Truth is confirmation of mind to reality, and actions, our dharma, should be to conform with this reality. To give you an example, for example, if you are on moon, it does not suffice to know that as a human being you need oxygen. You need to put on your oxygen mask with your oxygen cylinder. Only then will you be conforming to the reality of moon. If you say that I don't need to conform to reality, that there is no reality, and you don't wear an oxygen mask, then you cannot survive there, because you are not conforming to that reality. So our ultimate goal in life is to conform to this reality. But what is this reality? How do we know this reality? Science is all knowledge. The Greek word scientia means all knowledge, and the word school means to spend time wisely. So we are getting educated to think wisely about all knowledge and think about what is reality, so that we can conform our mind, our ideas, our intellect, and our actions to that reality. And physics is at the base of all this, because all the knowledge we have comes to us through our physical senses. All the knowledge, all the base of our knowledge is sensorial knowledge. Any knowledge you have comes from your senses, from the physical world. You rigorously analyze that sense knowledge and then gain intellectual knowledge. So those are the two kinds of knowledge, that there is sensorial knowledge and then there is intellectual knowledge. And this process is physics, because we are observing the physical world and we're putting the physical things first. And not putting physical things first then give us wrong values, a wrong understanding of reality. For example, there are many people who are studying physics or who have studied physics in this audience. And if I were to ask a question, like very simple question, like what is momentum? I open it up to you to reply to this simple question. What is momentum? Anybody? Are you?
Yes, anybody wants to tell? As a teacher, I would usually tell it's a product of mass and velocity, and it gives how much inertia to force, or how a body responds to a force that can be given by momentum. Others, please feel free to unmute yourself.
The amount of motion contained in a body.
Amount of?
Motion contained in the body. Is that correct, Subhakanta?
Yes, sir.
Yes, amount of motion contained in a body.
Okay. Anyone else? So all these definitions, like you were saying, Denny, that it is viewed as the product of mass into velocity, or amount of motion in a body. All these are sort of ill-defined, because if we say momentum is mass times velocity, what is this mass? Where does this mass come from? How does an object have mass? Then we say a circular definition, mass is something that is a resistance to a force. And then we say, again, keep defining things in a circular way without going back to the primary principles. And we get stuck.
Ramakrishna,
yeah.
Sorry, I want to interrupt. There is a question on the chat box. I'll just read it out. We can take it later also.
Okay.
He is asking whether won't the Bell's theorem contradict the X and Y approach? I'm not sure what. Akhil is a second MSc student. That's what he has put it there.
So before this is the problem that I want to emphasize on. Again, I'm thinking about this as the first lecture in a series of lectures. So when you say things like Bell's theorem, that I am not sure that if you properly understand Bell's theorem, what it is, because I'm not even sure if you properly understand what it means by wave function, because I don't know if you understand what a measurement means. Because if you understand measurement as the collapse of the wave function, that is not correct. Because the collapse is a non-physical thing, that we say that wave function instantaneously collapses, but there is nothing instantaneous. So I don't know about Bell's theorem and that X and Y, from what perspective you are asking. We have to set our basics right. So before the way to think always is things with a direct knowledge that we have, that we directly know. We must put things that we directly know first, and think always in terms of that, rather than thinking in a mathematical way about Bell's theorem without actually first understanding reality or what actually quantum mechanics means. So hopefully in this series of lectures we will get to explore what quantum mechanics means, because I will have to discuss a lot of things like ensemble interpretation and other things before we go to things like Bell's theorem that are much more abstract than the reality that we generally see, like a table next to me or an apple or something like that. So I want to start there. I want to start with the things that I can see, touch and feel, and take it from there rather than, start from Bell's theorem. That is the wrong footing. Because that is not what we know directly. We must always start from what we know directly. And to do that, I have made a list of questions here that I am going to address today in the next half an hour or so. And this would set our basis for understanding what breathes fire into equations. So first, we need to come up with rigorous definitions. Why rigorous definitions? Because our definitions must be precise, in conformation with reality, and completely be defined from things that we know directly. We should not define things in a circular fashion because that often leads to, subjective interpretations. And as scientists, we must be objective, and physics must be objective. And so if we start with what is physics, we can define physics as the rigorous study of the physical world. I will explain what this rigorous study means in some more time. But when we say physics is the rigorous study of physical world or physical things, what do we mean by a physical thing? Can anybody tell me what is a physical thing?
That which is known to us.
That which is known to us. Anyone else?
Something which we can get to our senses. Yeah.
Physical thing is something that we can see in the world.
Okay. So anyone else?
Something which occupies any space in vacuum.
Okay. So there is one problem in these definitions, because something which can be known, something which I can sense with my senses, all these things put me first. For example, if I don't, I should not be defining these things in terms of my experience. Those things exist even without human beings, right? We cannot say we don't know whether they exist without us, because clearly things exist, don't need our presence there. To have our knowledge in our... Sorry?
There is something on the chat, something which can be measured.
Something which can be measured. We have to... The problem with that definition is, what is measurement? We have not defined what is measurement. And we will talk about what is measurement. So we have to define things in a more primary way and not put ourselves in front. And the problem with the definition, like something that occupies space, is again, what is space? Is space something? Is space a physical thing? Right? So what is a physical thing? A physical thing is primarily defined by something that is limited, something that has extension, something that is something but can become something else. A physical thing is something, but it can be something else later. So it is something now, which is what we call as actuality or act, but it can be something else later. That is its potency. So a physical thing is primarily defined by the fact that it exists, independent of my existence, whether I see it or not, it exists. The moon is there whether I see it or not. So it is something that exists, and it's something that can change. That is the primary definition of a physical thing, that there is act, existence, and then there is potency, the ability to change. So that's the primary foundation of physics. So now I'm going to tilt my screen to right on the screen, so you may see the ceiling instead of my my face. So I would start with the first foundational principle of physics is that things exist, that a reality exists. It is this reality that we are looking at, this physical world that we are looking at, and physical things are something now, and they become something else. So these two, that things exist and things change, this is act or actuality, and this is potency. Or this is also often called form and matter. So here matter is not used in the traditional sense that we use in, but matter is potentiality. That is what it can become. So from these two, we know the principle of identity.
Ramakrishna, there is a question.
Yes.
The question is, what does exist mean? Okay, that's one question. Second part of the question is, how can we say anything exists without an observer?
Because we can clearly see that it exists without an observer. That is, you like the moon, right? You don't look at it. The moon is there. The moon is not going to vanish, right? For example, without human beings, the universe existed, or you didn't exist to begin with. Definitely, at the beginning of the universe, you didn't exist, but something must have existed. That's how universe came into being. So something must exist at the beginning. It cannot be nothingness, because nothingness itself is an idea. It's a mental construct. So all this must have come from something. So something must exist first, and only then you, me, or a rock or a tree can come. So something must exist. So that's the first thing. So existence, what is existence is, if you go back to the primary definition, for example, if you look at it from the aspect of the very beginning of the universe, then the essence of God is his existence. That is the way in which we would say what is existence for God. But if you look at existence of a physical thing, the existence of a physical thing is its ability to have one part outside another. That is, a physical thing is composed of many parts. That is its existence. So, but the existence of anything physical is ultimately rooted in the first existence of God. That, as Spinoza puts it in his Ethics, there is only one substance in the universe. The one, not even in the universe, there is only one substance. That one substance is God, and God's essence is his existence, and everything is sort of grounded into this. So it is as if the existence of the mirror image is dependent on the original source. So the image exists only insofar as the original creator exists. So that's a deeper question that we are going to ponder, but that something must exist to begin with, because nothingness is non-existence. That is the alternative. If something doesn't exist, then there is nothing, but nothingness doesn't exist. So that's not possible. So therefore something must exist, because I know that I am something and I must have come from something, because I cannot come from nothingness. So our first principle then would be that things exist. I hope I made sense. And then it changes. And then principle of identity, or put another way, the principle of non-contradiction, is a thing is what it is. That is, you can either have X or not X. It cannot be both X and not X. This is what Uddalaka explains to Shvetaketu in Chandogya Upanishad, that Shvetaketu has gone to his Uddalaka tells Shvetaketu that Brahmin, being a Brahmin, is not a caste or is not a thing, but Brahmin is somebody who realizes, who studies, and anybody who studies becomes Brahmin. And so you go to this teacher and learn, and he sends him to school, and he studies for so many years and comes back home. And then Uddalaka asks him the question, son, what is that one thing by knowing which I can know everything? And Shvetaketu doesn't understand the question, doesn't have an answer. So then Uddalaka starts teaching him from the foundational principles. And he starts with things exist and things change. And he starts with what is essence, that is, by knowing one lump of gold, you know all gold in the universe. By knowing one grain of sand, you know all the sand in the universe. And that's what he is trying to teach him. And he says that tattvamasi, he says tadasti. That means a thing is what it is. It exists. It is what it is. It cannot change without a cause. So principle of identity is you either have X or not X. This is what all physics is built on. Because if a thing is not what it is, then you can never know what that thing is. Right? I can know a thing For example, if you're looking at an apple, you can ascertain that that's an apple only if that apple doesn't change without a cause. If it changes without a cause, how are we to know that this thing has not changed by the time light has left that fruit and reached my eye without a cause? We cannot ascertain that if it can change without a cause. Only if it cannot change without a cause, we can say that whatever I am seeing is a faithful representation of what is there. So our knowledge depends upon this very principle of identity. If principle of identity is invalid, then all our knowledge is invalid. And then from the principle of identity comes principle of causality. This is very, very important to understand, because it is not principle of causality that is primary. It is principle of identity that is primary. A thing is what it is. So if a thing is what it is, it cannot give itself something it does not have. For example, a green banana cannot give itself yellow color, because a green banana does not have any yellow color in it. It has yellow color only as potency. That is, a green banana can become yellow banana, but it cannot make itself yellow. Only from the environmental causes and other things that act upon this green banana, green becomes yellow. Because something cannot give itself a property that it does not already have without a cause. So principle of causality can simply be stated as something cannot change itself, or in other way you can say nothing can change itself, or something cannot change itself. But this principle of causality then comes from principle of identity. So it is the principle of identity that is primary, because this is very, very important to understand, because the question that often comes up while discussing things like the creation of the universe is that you go back to a point and you say, okay, there must be something, because the universe cannot come from nothingness. There must be something. Then the question is, what caused this something? This is an irrelevant question, because what is cause? Cause is not primary. The primary thing is identity. Whatever this something is, it exists. And because it exists, then comes the causality principle. So nothing, there is no cause to God. God is the uncaused cause, because cause is not the primary thing. Principle of causality follows from the principle of identity. That is, a thing is what it is. God is who he is. There is no cause. There is no separate cause from God that can cause God. That identity is primary. That essence is primary. That's why it's very, very important to put first things first. The first thing is things exist, so things can change, and things cannot change without a cause, because a thing is what it is. It cannot give itself something it doesn't have. And when we put it into these first four principles, we see that the principle of identity is primary. And that naturally leads to God as the uncaused cause. Then the fifth property is, this is the most important thing that is very, very important to every physics and every science student. What is substance? What is a physical substance? We define a physical substance as something that can exist by itself, and a property as something that can exist as a part of the substance. For example, think about color. What is color? Is color a substance or a property? Try to think about red. Can you think about red as such? Don't think about a red wall or a red square or red something. Think about red as such without attaching something to it. Even if you think of red like a square or a screen painted with red, or if your mind is flashing images of red, like red blocks or red squares or red something, it is not just red by itself. You're seeing red something, and that's how you know red. Because color is not something that exists by itself, it rather exists as a part of something else that exists by itself. A physical thing that exists by itself is what we call as substance. For example, an apple tree would be a substance. It exists by itself. But color of an apple would be a property of that substance. Color itself does not exist independently. Color exists as a part of that. Mass won't exist, doesn't have any independent existence. Mass exists as a part of the substance. Or temperature doesn't exist separately. There is no something called temperature. Temperature exists as a part of the substance. So substance is something that exists by itself. And a property is an aspect that exists as a part of the substance. This is very, very important distinction to make. Because, as children, we are very inquisitive and we often ask questions like, why is the sky blue? And then you immediately hear people answering things like, oh, blue has short wavelength and so it gets scattered a lot, so then the sky is blue. But what should we instead be asking children is, what is sky? Is sky a substance? Or is it a property? Is it a real thing? Or is it a being of reason, like nothingness? What is it? Is sky a physical thing? What is blue? Is blue a substance or a property? Or if it is a property, what does it reside in? We should ask this more than explaining it with some equation-only physics, like, yeah, blue light gets scattered by 1 over lambda 4 as Rayleigh scattering. That is the mathematical explanation devoid of reality. Because an Albert Einstein asked himself fundamental questions like this. What set Einstein apart? Did Einstein have a supercomputer that everyone else didn't have? No. What set Einstein apart was he dared to ask these fundamental questions. What is sky? Is sky a physical thing? Is ether a physical thing? That's the question he dared to ask. And that's what he found through general relativity, that space is indeed a physical thing. It is not mere extension. Space is a physical thing that bends, that warps, and all these things happen, and it has properties like light. Light is a property of space. That's what Einstein showed. And so that's what we should be asking. So when a child asks, why is the sky blue? Or when you ask yourself, why is sky blue? Or any other question, you must ask yourself, am I talking about a substance or am I talking about a property? So I ask the question, what is momentum? Then the question is momentum a substance or a property? If it is a property, what kind of a property it is? Because we can divide properties into different things. For example, we can look at any physical thing and look at the base property of any physical thing. The base property of any physical thing is what we call as quantity or extension. That is, any physical thing has length, breadth, and width. Even if you think about an electron has a length, breadth, and width. And some dimension, it may be very small, very tiny, 10 to the power minus whatever centimeters, but definitely it has extension. And what do we mean by this extension? We mean by having one part outside another. So if you take a scale, it has one part outside of another, right? And that's how we are able to say that it has extension, that it is extended. That I am able to stretch my hand because space is extended. That's how I am able to stretch my hand, because space or physical space has one part outside another. But it is not nothingness. And this is an important thing that often leads to nihilistic view, because we often think about space as nothingness and we say atom is mostly made of nothingness, or something between Earth and moon or Earth and sun is not nothingness, it is physical space, it is something. So a funny story here is that Feynman went to Princeton, got his PhD, went back home, and his father asked him, you now have a PhD in physics and you can explain all these things. And he said, may I ask you a question? And Feynman said, of course. And Feynman's father asked him, they say the atom is made up of electron and proton. And Feynman replies, yes, that is right. And then Feynman's father asked, but they say that when the electron is excited and comes back, they say it emits a photon. Then Feynman says, yes. And then his father asks, initially there was electron and proton in there, and finally there is electron and proton in there, in the atom, and there was no photon to begin with, but where is the photon coming from? And Feynman couldn't actually answer him. Because if you think about it, where is this photon coming from? You may say it is coming from, energy, but where is this energy? And, we say electric and magnetic field. Where is this electric and magnetic field? These electric and magnetic field are in space. Because the space is a physical thing, it is a substance, and electric and magnetic fields are properties of this space. And so light is a property of this space. So this space is a physical thing. It is not just mere extension. It is a physical thing, just like how an apple is a physical thing. So quantity is the base property of any physical thing. And then it can have qualities, like for example, it can have mass, it can have temperature, it can be hot or cold. All these are properties. And then we have extrinsic properties, extrinsic categories. That is, I can do relation, that I can say this physical thing is bigger than that physical thing, longer than that, or I can say this thing is heavier than that, so I can relate them, right? And then there is activity and reception, that any physical thing, this is not action and reception, action and reaction like in Newton's laws, but this is activity. Any physical thing has the ability to act on another physical thing. Any physical thing has the ability to receive action from another physical thing. For example, if there is an electron, it has the ability to act on another physical thing called space, and this space has the ability to receive the action of electron in terms of electric field. So that is activity and reception. And then there is place, there is orientation. So when we look at place, for example, imagine there is only one thing. How would you define its place? If there is only one thing, you cannot define its place. Anything we can only know as it being embedded in something else. Like for example, you can think about different statues, but these different statues, you would be imagining them in some sort of a box, right? Even when you think about the universe, you think about this universe as in a box. And so by comparing physical things, we can say that is here and this is there. That's how we get the distinction of when we say the ball moved from here to there, we say that it moved from here to there with respect to other physical things. So our notion of place comes from comparing things. And then similarly, orientation, that, our directions come from comparing different things. And then we have environment. That is, for example, the environment of fish is water. And the most important extrinsic property is time. What is time? Is time a substance? Definitely not. Time is not a real substance. It doesn't exist by itself. Time exists because things exist. That is the primary thing, that something exists. And that something can change, that is, it can have potency to change. And so when something changes, the duration of that change is what we perceive as time. So time is duration of change. Things exist, that is the primary thing. And then those things can change, and if they change, the duration of that change, for example, the ball is here and the ball goes there. So the duration of from going here to there is time. But change is what is primary. It is not time that is primary. Things don't change in the background of time. Because things change, there is time. This is very, very important, because think about now the beginning of the universe. We say that there is something because the universe cannot come from nothingness, but this something exists by itself and there is no change. And in Bhagavad Gita, Krishna says achintya. What do we mean by God is achintya? That there is no chinta, there is no thought. And we say nitya, What do we mean by nitya? We often think about the word nitya in a very poor English translation, that it exists today, it exists tomorrow, it exists daily. But our notion of today, tomorrow is related to change. But nitya means na itya, no change. That is, it is beyond time. That God is nitya means God is beyond change, beyond time. If there is change, the duration of that change is time. Time is not a background that flows. That, when we talk about the beginning of the universe, before the beginning of the universe, there was no change. There was definitely something. It is what it is, but there was no change in it. Because it has everything in it, and anything that you can think of is a part of it. So it cannot, for example, if yellow is a part of the green banana, then even if it becomes yellow, we don't say that it has really changed if it's part of that. So the something that exists in the beginning, that has everything, so there is no change there. And when there is no change, it is nitya or achintya, no thought, because thought is also related to change. So time is an extrinsic property of physical things. And then what is measurement? Measurement is the comparison of one physical thing to another thing. So when we say this thing weighs 1 kilogram, we mean that there is a standard, an iridium cylinder that is sitting in Paris as a standard in some museum somewhere. And then I say this physical thing weighs as heavy as that standard cylinder. That's what I mean. When I say the distance from here to there is 10 kilometers, then I mean that the distance from this point to that point is 10,000 times a standard unit that is sitting in some museum. So it is a comparison. But we know extension as a property first. We look at physical things first. We have our knowledge that comes from our senses. So first I look at physical things. So when I look at physical things, the first thing I know is that this physical thing has one part outside another, that it is extended. I look at a table, I see that this table has one part outside another, that it is extended. So I know the property of extension or the property of length. Because I know the property of length, I make a comparison of length between two objects and therefore measure it. You know it, so you measure it. It is not the other way around. You don't know by measuring, you measure by knowing. And this kind of misconception comes from David Hume, who said that if you cannot measure something, you cannot know it. That is completely wrong. Only if you know something, you can measure it. Because you see physical things, and you see that these physical things have extension one part outside another, you have this understanding, this innate understanding of the idea of extension, you measure it. You give it that measure of length, and you call it 1 meter. And same thing with time, because we perceive, we see changes around us, we compare one change with another. For example, you can sit down and you can count your heartbeats and say you are sitting in front of a grandfather's clock with a pendulum that is swinging. And you count your heartbeats and you count how many times the pendulum swings. The pendulum is swinging, that it is moving from one point to another point, that is, it is changing in its place. Your heart is beating, that is also changing. You are comparing your heartbeat, one change to another change, that is the pendulum swinging, and you can establish a measurement of time by comparing two changes. But this time, when we say it is 10 seconds or 10 minutes, it is not a background. The measure of time is simply comparison of two changes. And we see time, we perceive time because things change. Things exist and things change. Things don't time, things change. So what is mathematics then? Because this is very important to understand, to look at what is an equation actually, before we understand what breathes fire into the equation. I know that I have spent 54 minutes, so I'm going to wrap it up in next 5 minutes. But what is mathematics? We look at the base property of any physical thing. That is, when we say it has one part outside another, so we abstract the notion of number from a physical thing. We also abstract the notion of shape from a physical thing. So the notion of number is, you can say, arithmetic, and the notion of shape is geometry. So it is from physical things, by looking at physical things and studying the base property, that is, all physical things have extension. They have a number of parts, one part outside another. From there I get number. A physical thing has shape. It has boundaries. From this I get shape. This abstraction and the study of quantity, the base property of physical things, is mathematics. Mathematics is the study of base property of physical things. It cannot exist without physical things. And what is the modern scientific method? The modern scientific method is this number and shapes have existed for eons, even before, well before us, as you know, well before Newton. But what did Newton do? Newton and Descartes mainly, they have established a bridge between these two using analysis or algebraification of geometry. Now I do not only have geometry, that I not only have a circle, but I can give it symbols and write this circle as x squared plus y squared is equal to r squared. And then I can use these symbols and rules to manipulate and write down physical laws. So that's the modern scientific method. Often you hear people say scientific method is you make a hypothesis, you test it, you validate it. But this has existed ever since Yajnavalkya and Kapila and Plato and Aristotle. What is so modern about it? The modern thing about the scientific method is we understand generalities from particulars. That is, you can touch one particular glass of water and realize what is coldness in general. And then you can express this general understanding using symbols and rules to make laws that predict what is going to happen. So physical laws do not exist. God has not made the universe with physical laws. Physical laws are our attempt to look at the physical world through the idea of quantity, through the physical nature of things, and make these laws using symbols and rules for our convenience to predict. So when I write f is equal to ma, it's an equation, or f is equal to dp by dt, it's an equation that I am making by observing physical things to predict the general laws of nature. And mathematics itself has no change. For example, if you say this is motion of a car, x versus t, this is how the car is moving. Here you consider as if all these points on time exist at the same time. But in reality, that is not the case. This movement exists now and that movement comes later. So you don't make any distinction between what is right now there and what is going to happen. You sort of combine all these points, the mathematical time, as if all these times exist at the same time. If all times exist at the same time, mathematics really does not capture any change. There is no change in mathematics. People often think that this dx by dt is a change. This dx by dt is not a change, it is a derivative. I have abstracted this x as a notion from a physical thing. And I have also abstracted the idea of change, and I can measure two changes, and that's how I have come up with this extrinsic property of time, and that is what is this dt. But that is not the primary thing. Dx by dt is not the primary thing. There is no change or no cause in mathematics. And because there is no cause in mathematics, a mathematical equation cannot describe its own cause. For example, if I have f is equal to dp by dt, you can say, oh, this equation describes the universe, or even, you can write down, Einstein's equation, r mu nu minus whatever is equal to, t mu nu. The stress energy tensor, then the curvature of the universe, and this explains the universe. But that's not so, like how Stephen Hawking says, or how Richard Dawkins says, because an equation cannot explain its own cause. How did this equation come here? An equation does not explain its own cause, so because the equation itself contains no cause. The equation is meaningless. For example, if you're looking at a computer screen, the computer screen makes sense to you, the words on the computer screen make sense to you because you are the one, your intellect is the one who is looking at these words and reading it. Without that intellect, these symbols on the computer screen have no meaning. So the equation is just symbols and rules that we made in our modern empiriometric method, modern scientific method, to make laws that predict the universe. They do not contain any causes. They do not explain anything. So what breathes fire into the equations? What breathes fire into the equation is the first thing that existed without any change. What is that? To understand that, we have to think more deeply about these fundamental principles and start from fundamental principles and redo all of our rigorous physics, relearn calculus, see what actually a vector means, understand vectors, calculus, tensor algebra, tensor calculus in more fundamental detail by putting physical reality first, physical things first, and then we can understand the thing that actually breathes fire into these equations, the uncaused cause or God. And thereby we can understand what our consciousness is, why we are here, what our purpose is, and how should we learn and how should we live. And that's how we can combine the dharma with our physics, because dharma is what we ought to do, and that only physics can teach us, nothing else, because without understanding what our reality is, we cannot say what our dharma should be. We can only say what our dharma is insofar as we know what reality is. And so physics and dharma are on the same line and on the same bridge. And I feel that at an institute like Parthi and Vrindavan, all the students, this is what I feel, in my opinion, humble opinion, Swami wants us to do, that learn these things in a real way so that we can combine by brushing up our basics, by setting the basics, by setting the ground rules properly, initiate discussions where we can combine the best of our spirituality, the concepts of Akasha and Prana from our Upanishads with general theory of relativity to discover things like quantum gravity and to discover new vistas of physics that are aligned with spirituality rather than just getting trained in Python and machine learning. So let's think more deeply and more widely, and let's dare to dream like Einstein, and let's dare to dream like Yajnavalkya, and let's dare to make something out of our life so that we conform our minds and actions to reality, and offer this as a humble offering to Swami. Thank you.